can be corrected. Okay. So here's the second question. A cyclotron is designed to accelerate protons. So we're going to start at rest near the center, and it's going to spiral out. If I can draw this spiral, with an outer radius of 0.330 meters, and they're emitted nearly at rest from a source at the center. And each revolution, so each period, is a delta V of 600 volts. Or maybe I'll write this. Each delta T goes through delta V of 600 volts. And then we've got a B field of 0.550 Tesla, which is keeping our proton rotating. So the B field must be out of the page. So if we put from our right-hand rule, if our proton is moving to the right, QV, and our B field is out of the page, then our force is QV cross B. Now this doesn't matter too much for what I've drawn here, other than just for consistency. Then our force would be, put our fingers in the direction of the QV, our palm in the direction of the B field, and then our thumb would point in the direction of the force. So our fingers in the direction of QV, our palm in the direction of the B field, and then our thumb points in the direction of the force. So that's what's giving us our circular motion. In this case, I drew it this way, and if it was wrong, then the spiral would just be the other way. But it looks like I drew it the right way, so it's attempting to go in a circular motion, but then each cycle, we're pushing the kinetic energy higher, which is pushing the circle outwards. So I suppose it actually should be drawn something more like this. Which I can't do, but the maximum radius is 0.330 meters. So our force is QVB. I've gotten rid of the cross product because they're perpendicular to each other, so it's just going to be QVB. And I've also gotten rid of the vector notation because the magnitude of the force is going to be our centripetal force. So it's going to give rise to our mv squared over r for our motion. Which we can then use or solve for our velocity for our proton by rearranging for the velocity. So first we can cancel this velocity and cancel the square, and then we can rearrange to say that QB over M is equal to V over R. And I left the R on this side because our omega is V over R, so that's our angular frequency, or QB over M is equal to omega. So then each period we go through a delta V. Let's just run through the answers to the question. So that is our cyclotron frequency. So that's our frequency for our motion. So that's how we are going to get it. So for A, omega is the charge of an electron, 1.6022, charge on a proton, which is just the positive of the charge of an electron. So 1.6022, 10 to the minus 19 coulombs, times B, 0.550 Tesla, over the mass of a proton, 1.672622 times 10 to the minus 27 kilograms, which is 52.684, 10 to the 6, 1 over seconds. So there's our cyclotron frequency. Find the speed at which the protons exit the cyclotron. So V is omega R. So omega is not going to change as we as it goes around and around. It's still going to have the same cyclotron frequency because the charge, the B field, and the mass are constant. The only thing that's going to change is the radius at which it orbits. And at the maximum radius, our max is given as 0.330 meters. So our V at maximum is 52.684 times 10 to the 6, 1 over seconds, times this 0.330 meters, which is 17 times 10 to the 6 meters per second, which is very high, right? So it's, remember, the speed of light is 3 times 10 to the 8. So this isn't quite there, but it's getting close. So that C, find their maximum kinetic energy. So kinetic energy at max would be 1/2 the mass of a proton times our Vmax squared. So mass of a proton is this 672,622 times 10 to the minus 37 kilograms times our speed at max squared. And that equals 2.528 times 10 to the minus 13 joules. And then just converting it to EV, which is kind of a nicer unit when dealing with these kinds of units, which is the conversion factor is just the charge on an electron in joules per EV. So our joules are going to cancel, leaving us with EV 1.578 times 10 to the 6 EV, which is about 1.6 mega EV. And that's also just as you go on with your physics learning, you'll start to figure out kind of ranges of things. And I think a cyclotron, which gives you an energy of about in the mega EV range, sounds about right. So that looks like we're doing things correctly. A lot of times that's a good way to check that you're not making any mistakes. Okay, so how many revolutions does a proton make in the cyclotron? So we know that our delta Ke is 600 volts per revolution, right? So we said for each period, we go up by 600 volts. And we can convert this to EV by, our delta V, I should say. And we can convert this to a delta Ke by multiplying by charge. So 600 volts per revolution times the charge on a proton. And then we can convert it to EV by dividing by the factor, which is just the charge, the charge on an electron, which is the same as the charge on a proton. So those are going to cancel, except for the coulomb. And a coulomb volt is a joule, so then the joules will cancel. And we're going to be left with 600 EV per revolution, which makes our conversion to, when we convert it to EV, that's going to make this significantly easier. So then if our Ke max, if our Ke initial is 0, and our Ke final is 1.578 times 10 to the 6 EV. And we have a delta Ke is 600 EV per revolution. Then the number of revolutions is just our 1.578 times 10 to the 6 EV minus 0, minus our initial, which is just 0. So I might as well just include it just for fun, over our 600 EV per revolution. Now, revolution isn't really a real unit, but I'm just keeping it around just so that we can work with it kind of to calculate our number of revolutions. And so we see that the EVs will cancel, and we'll have revolution upstairs. So that kind of means that this little equation is correct. And so if we do this math, it comes out to 2629.6 revolutions, or 2629 full revolutions. So we'll get through 2629 full revolutions. Okay. And now for what full time interval does a proton accelerate? So our omega is 52.684 times 10 to the 6 rads per second. Again, rad isn't a real unit, but it sometimes helps to differentiate. Our period is 2 pi over omega, which is 2 pi over our 52.684 times 10 to the 6 per second, which is 1.193 times 10 to the minus 7. And this is in seconds per revolution. Again, revolution not a real unit, but just to keep kind of track of things. So if we have 2629.6 revolutions, then our full time will be our 2629.6 times our period, per revolution, so 1.193 times 10 to the minus 7 seconds. Okay, and so that comes out to be 3.1361 times 10 to the minus 4 seconds. So then that's our that's the time that a proton spends in the cyclotron. Okay. So now going through each of these. So here's our frequency, 5.26 times 10 to the 7. So I've got 52 times 10 to the 6, so those are really the same. And I've kept quite a few digits. Obviously, it should only be 3 digits for significant figures. And then the rest is just rounding differences. Our velocities are the same. Again, I should only have 3 digits for significant figures, but that's okay. C, our KE max, 1.58 times 10 to the 6, 1.56, so I'd say that's probably, again, rounding differences. During the time interval t over 2, the energy of the proton increases by, I must have misunderstood perhaps. The protons are from a source at the center. Each time they cross the gap between the D's are between the poles. Oh, I see. So that was my mistake. So it should have been like this. I see. So then delta KE is, delta V, delta V is 600 volts here, and delta V is 600 volts here. So it actually increases the kinetic energy twice in a revolution. So I'm doing it for once per revolution. Okay, so then my delta V should be 2 times 600 volts per revolution. So then this should be 2 times this, so then 1200 EV then per revolution, which significantly changes things. So again, 1200 EV per revolution. So then the number of revolutions here actually halves, giving me, I'm just going to do this here. So my apologies here. So it should be just 29.6 divided by 2. So this actually should be 1314.8 or 1314 full revolutions. And then the time spent will just be this value times our 2 pi and divided by our frequency, which is 52.684 times 10 to the 6. So then our our time in will actually just be 1.568 times 10 to the minus 4 seconds. Not these values. All it really does is have everything, because I was doing the calculations for one, and I apologize for that. Here though, so that's not correct. It's not, we needed to divide by the conversion factor to EV, which was a mistake there, which makes the revolutions quite significant there. And then obviously that's going to carry forward to there. So let's say demist conversion to EV. Mistake carries forward to E. Should be D is about 1314.8 revolutions, and E is 1.568 times 10 to the minus 4 seconds. Okay. So I'll just say it's incorrect just because of those